Starting this Cloudera. Once this is up, then we'll see other activities of HBase. I think this will take another couple of minutes. So let's start theory part. Here we want to store data in HBase cell, but so far we are testing it one by one. We are inserting data using one query. First, one column family, then in that column family, we are providing one column identifier, and we're giving entry for that value. Suppose I have a big file and I want to store that data into HDFS. So what is the process here? This is the concept is known as a bulk loading here. Okay. This is bulk load of a file to HBase database. Now to perform this bulk load, we should know what is the file type. So first, create a file. You can create file with any extension, TSV, CSV, JSON, any data can fit here. Now to create a file, we'll go to local and we'll say cat. This is how we create a file, cat. Then we can store any data. Let's say total data set related to test.csv. So we have some transactional data. Okay, suppose. So we have transaction ID as 1, 2, 3, and we have their other column. So it's a TSV file, not a CSV file. Tab separated value. First, I will take TSV, then CSV and other file format also we can check. TSV means tab separated. So one, then what is the transaction type? It's a transaction from saving account or credit account. That detail is there. And then again tab separated. Third is a total transaction, which is let's say 1500.00. This credit is 8000.00 and 5500.00. So we'll create this file first. After creating this file, we will load this data. So second step is copy data to HDFS or copy file to HDFS. I should say file, copy file to HDFS. What is the command to copy file from one system to second system? It is HDFS DFS hyphen put, then source and destination. So source is my test.tsv file if I'm in the same directory, and destination I can give anything, right? Let's say this is destination of HDFS table. Slash means it is going to root directory. Then third step is to create a table in HBase. Create table in HBase. Now, how do we create table in HBase? First, we will go to HBase cell, HBase cell, and we will get this cell option, HBase. This cell we will get, and here we can start creating a table. We can say create table name. I will give as txn, comma, column family. Now you want to store this both result in one column family or different column family. That's up to you. Suppose I want to store this transaction type and their total amount in one column family. So that column family name is transactional information, right? So this txn info is my column family and this is my table. Now, why I'm giving this structure? Because I know the first column will become automatically my row key, and these are column wise entry. This will store in a column identifier, which I'll define at runtime. Now, after this, three different creations, creating file, then loading that file or copy that file to HDFS, then creating table in HBase. Fourth command is to run a bulk load query. Run a bulk load query. This bulk load is allowed in RDBMS also. So let's see here directly. We'll create first a file using this terminal. HBase cell, and we'll open our HBase file here. So here we have HBase folder, and inside this we have HBase bulk query. So we already have seen till this third step. This step is important for us. The last one, which will load data. This is a CSV data. I will test it for TSV, this file format. Okay. So create a file first in this location. We'll try using list command. This is like a show table. If your all demons are up, this will work. Otherwise, if hreason server, hmaster, and quorum pyramid, they are not up, so we get exceptions here, right? Create one table and give a name as txn, comma, txn underscore info. So this is my table name and their column family. It is created. Again, type list command to check transaction table is there. Yes. Now in this table here, from this HBase cell, we will not do anything. We'll do all thing in this terminal. Create the file first, cat and txn.tsv. So TSV extension is required. Then we had one tab saving, tab some amount, 1500.00. 2 is credit, 9000.00, and 3 is again saving, 5500.00. Okay. After creating this transactional data, we will store this in HDFS using put command txn.tsv slash. And third step is already there. We have created a table already. After table creation, I'll copy this line and paste in my terminal. We'll wait for this. Right click and paste the query. Now what I'm writing here, we said HBase, and then we are giving one package name here. And this package is already created. You can see the package org.apache.hadoop.hbase.mapreduce.import tsv. So this package is specially created for TSV dataset only because I'm using TSV package. Then you may ask if we have other package, we will use one separator here. If other data type is there like comma separated or something, we will use their delimiter. Here we'll pass one more field. We'll check first with the TSV, then for CSV we can see. D import columns. This D stand for direct import. Okay, so D import column HBase row key. Now from this query till this query, you'll have to write as it is. Whatever is written, you have to write from this point to this point. After that, we are saying CF1 country and CF2 diplomates. So till this highlighted area, you have to write as it is, exactly same. You will change this CF1 country, CF2 diplomates, this thing. So let me change it first. What is my column family name? So column family name is txn underscore info. We can check that information from our HBase cell. txn underscore info. This is your column family. Now, again, we'll go back here. txn underscore info is my column family. And here we will store our column identifier. So column identifier is, first one is card type. Okay. Then I want to store the second column identifier also in my first column family. So I'll use the same column family, which is txn info. And this is the amount, transactional amount. So I'll give name as AMT htest. What is your table name in HBase? That is a txn table. And what is the file name in HDFS? That is, we can check here. What is our file name? It is txn.tsv. It is txn.tsv. Now we'll read this query again. HBase. So one common mistake which we do, we try to run this query in HBase cell. We are not running in HBase cell, we are running in normal terminal. So check this first. HBase, we are giving a package name of TSV, import TSV. D stand for direct import. HBase row key. Till this part you will write as it is. Till this key you'll write as it is. txn info is column family, column identifier, column family, column identifier. txn my table name. This is the file name. When I run this operation, you'll see what will happen. One bulk load will start, but what is the internal process? How this data is going to store in HBase with the help of which programming model? So this programming model is MapReduce because you can see this package is coming from MapReduce. So it's a batch process because this is a batch data. It's not a real-time data, right? I have stored this data in my system somewhere, and from there I'm uh, storing this data from HDFS to HBase. And after this, we will check where in HBase this data goes in HBase table and how this data is storing in HDFS. Because if I go and see the architecture, so far we have created our centralized unit. So HDFS was one which is storing the data, and this layer we call as, this is a storage layer. HDFS is known as storage layer, right? Then second one after HDFS we have second storage, second application layer, and that application layer is TZ MapReduce or Spark. But in between this application and storage, we have seen one more layer, that is YARN. YARN stands for yet another resource negotiator, and there is a mesos also, which is created by Apache. Now, this second layer we're calling as computation because this is computing my data set, right? Whatever is stored, they're computing it. And after this computation layer, we have a top MapReduce. I will write first because we have seen this Spark and we have seen this TZ also in Hive, how this TZ works. Now, this is the application layer. All good. Whenever we write anything or process anything, it goes to MapReduce or Spark. They process it using this backend services, and at last they write this data to HDFS after selecting few percentage of your system computation resources, which are CPU and RAM. After this part, where Scoop and other details are, Scoop, Hive, all they are running at top. This is why we are calling it's a ecosystem. Scoop is ecosystem, Hive is ecosystem, where HBase is. Because Scoop is using HDFS to store the data and MapReduce to process the data. So Scoop is using both Hadoop utility. Same thing goes with Hive also. Hive could use any one of them, MR, Spark, and TZ. TZ we have seen, Spark also we have seen how to run a query using a Spark to Hive, and they are also storing their data to HDFS. Now HBase will be right there. HBase storage is this area, I can say storage for HBase. So it uses the part of HDFS only, but HBase uses some internal concept. In architecture, we'll see how they store their data to HDFS. So ultimately, the final copy of HBase will also go to HDFS. This is using HDFS storage only, or centralized storage area. Okay, but how they are using in low latency format, that logic we need to understand, that concept we need to understand, because HDFS we already know, and we have compared this to HBase versus HDFS. Now this is done, and we'll see output is stored. Map 100% reduce is not required, so reduce 0%, and we have written total data. We'll check that in our HBase table. Now, how do we check whether data is present in this table or not? So we will scan this using table name scan and txn. When we check scan and txn, this data is stored from your file, HDFS file to HBase. So we are checking data in a columnar basis. Suppose I design this data graphically, how this will look like. Graphically, this data will be with row key, row underscore key. I'm calling this as a row key. Then I will have column family, which is txn underscore info. So let's write here txn underscore info, and their column identifier, which is AMT and card type. So AMT is there at first, and card types I'll write as follows: AMT and card type. By default, they will select data in a alphabetical order. So if you're thinking earlier when we created the data, so card detail was before amount. Now why amount is coming first? Because of they have selected this column based on the alphabetical orders. A to Z, you can see A is coming, then C is coming. Okay. Row key is 1. Amount is some amount, which is this 1500.00. And what is the type of card? This is a saving card right here. Saving. This is your first row. And one timestamp is also there. Okay, which is not required for now. Then second row key. Row key 2. This is having amount as 9000.00, and their type is card type is credit right here, credit. Third entry is 3. This amount is 5500.00, and this result is saving result. So this is how data is displayed. Now there could be n number of query. You can say I want to search for let me argue a question on behalf of you. First question I'm asking, I want to see only result from row number 2. I'm saying only result from row number 2. Only result from row 2. This is one query. Then you said from row 2 I want to check only amount. Second query you can say only amount from row 2, or you could say amount from all the row. So we can use whereby conditions like we use in SQL. Select a star from table where condition is equal to this or in between this. So we can use all where conditions here, just like we have seen in Hive data warehouse. Their syntactical part were very similar as SQL RDBMS. Here we are using a JRuby language. In HBase, this is a combination of Java plus Ruby, whatever I'm writing. Now, here after this, I will go and run some query. So bulk loading is done. So filters. This is the command which we will use for selecting the filters. Filters means that where condition is known here in HBase as a filter. So we'll be using filter query to check result between one number to second number. You can ask anything, any question. We'll see one by one how this will be done. Now, can I go to HDFS directory and check this result? So HDFS DFS minus ls, and there is one username created as HBase. Inside this HBase, we will have all the detail. Let's see. So we'll go to that directory first and give this folder name. HBase, today, according to this machine, what is the date? Date is 7/1955. We can see their recursive file hbase ls -r. R is for recursive. So we are asking show us the complete result inside this folder, because all HBase data goes to this folder. There are so many folders created. And where is my data? I want to check my current result. If I check this, this is one entry. Let's see one by one. So this is a file which is having size is 83 bytes. So I'm checking from here. Maybe I'll open another terminal and there I'll check SDFS, DFS, or let's use the direct query, paste SDFS, DFS minus cat. How this structure is coming, we will check that. Structure info. You can see this is my latest entry. Okay, let me increase the size. This is my entry because we have stored our this data currently txn info. So txn info, and this is my information stored. This is coming in some encoding format. Okay, these are some other data details. These are detail coming from other tables. Last entry is my current detail. Now in HBase we know how table how data will be selected. Now we will check our query from HBase filter. This is for CSV dataset. TSV we have seen. In CSV you are using this thing only extra. So instead of calling the direct column, you are anyway using this. This highlighted area is new thing in CSV. You'll have to specify separately what is the delimiter. So similarly, if I use any other format, I'll have to specify the delimiter here. Import tsv dot separator. Inbuilt package for CSV is not created, so we will use the same package as earlier tsv, and here we will give one delimiter as comma. So it's a CSV file internally, it will understand. Then I'm giving my file which is having a CSV extension. After this part, where is HBase filter query? Sorry, HBase filter we have present here. Now these are all filter operations. So as you can see in this file, roughly we have 17 to 19 filter options. You can filter by column, you can filter by time, page. Let's see, the first query is first key only filter. So right click and save this. Here I will change my table name. So I'm running all this query on my txn table. Here I'll give txn and filter. What do you want to filter? You want to filter first key only filter. When we run this query, we will get our first key. Check this filter operation we're running for. We are saying from this result, only give us first key. So you can check in first key. This result is having, this is my first row column identifier. So first key is having this value, first for all, row key amount. That's why you're only getting this amount. So first key only filter will give you whichever column identifier we have it first. Suppose I have two column families, so second column family, first column will also come. Okay, if they are with a different row key. So this result is coming based on the row key. Only the first key column identifier. You have n number of column, that doesn't matter. We can check that this query with our previous table also. And what was my previous table? We had created this 8 a.m. demographic. Okay, and here I have two column family. Let's see. I just need to change my table name. 8 a.m. colon demographic. So when we run this, we are getting result only from first column family, which is personal, and from that first column family we are getting first column. Okay, let's see, let's just scan this. table 8 a.m. colon demographic. Now in R1, can you check which column is the first coming? So in R1, we have first column card detail, which is there. In R2, we have first column as loan, it is there. And in R3, we have first column as card detail. This is also there. So based on their first data is loaded in the table, obviously they follow the alphabetical order. So based on the alphabetical order, this data is sorted, which will come first, second, third. It is decided here. Now, after first key only filter, we want to check some other. So this is a key only filter. Now, what we will do in key only filter, right click and paste it. I'll test this for transaction table. Okay, so TXN is the table. First key only filter means you will get only key, there is no value, because here we are saying key only. And I did not say first key or second key, I said key only. That's why all the keys coming here, all result is coming but without value. So we will get to know how many column identifier is there, but we cannot check the value using this query. This is just giving us the key result. Then we have, let me change this, result of HD colon demographic to TXN. Okay, so we can copy and directly use it. Third query is TXN filter prefix filter R1. Now what is this prefix filter? I'll remove this R1 and check here. Prefix filter is like select a star from table name where row is equal to 1. This is like you're limiting your result for row key number 1. This value is from row key. Okay, so prefix filter 1, if you type, you will get all the column identifier along with the column family for that key, right? And this is the result. If I check my table, I think I'll create in this space, which is a free space, row key, because every time we'll have to come here and validate our result. Row key, transactional information, and then within this column family, we have created a column identifier that was saving card and credit card. It's a card type or card detail, card type, and the second one is amount. Amount is starting with A, so A will come first, AMT, and card underscore type. Then we have stored result 1, 2, and 3. Some number we have 1500.00, 9000.00, and 5500.00. Card type was credit, saving, and this two are credit. Any entry, by the way, we can insert it in this. Now the query which I'm running, page prefix filter. Prefix filter, I'm giving this key 1. So this result is displaying because this result is related with 1. Is there any option which can give me 1 also and 2 also? So here your row key is working as a primary key. Based on the row key only, we are searching the result. So prefix filter is specifying the column identifier from 1. Then we'll check next. Prefix filter and column prefix filter. So here now I don't want to get all the column identifier of row key 1. I want to get the card type of 1. I want to get this specific result. So when I want to check that specific result, like this one only, this saving only, Now here I will use my column prefix filter also. Earlier it was just a prefix filter. I will use this prefix filter with column also. So filter prefix filter, you can give that column first row key, and then which column you want. You want from txn info colon. I think column family name is not required. We'll check if this works good. Otherwise, I will remove this and check for txn type. Yeah. So we just give here a txn type, and we get result related to R1, because here I'm already fixing. I want result from row number 1, but I want this column identifier. So this is just a one result. Then can we use multiple column prefix filter if I want to check multiple column out of this? So multiple column prefix filter, here you are not defining the row key name currently, you are defining only the column name. Suppose I'm giving one column name as AMT currently, just AMT. Okay, let's remove this. Just AMT, if I'm giving, it is giving me AMT from all the row key. Suppose I give one more column, which is a card type. So copy from here and paste it there. This will give me result of the whole table. So that row key, that column identifier we have selected. Then if I want to select multiple columns without any row key, I can select it. I can select one column from all the row key, that also I can select. Now after this, we will set our prefix filter also with multiple columns. Prefix filter with multiple column means I want to check this result from row number 2, and multiple column prefix filter. Here I want to check from row 2. What is there? Anyway, here I have just two column identifier. So this query is not important. You can write prefix filter 2, and this will give you the same result. Card underscore type. Card underscore type. This is like prefix filter 2. This result, if I set 2 here, and if I check this result, both are same. This is good when you have multiple row, multiple column identifier in your column family. This is helpful for that time. Suppose you have 5 different column identifier in one column family, and you want to check only 2 column identifier. So we can use this multiple column prefix filter. Then page filter. Page filter and prefix filter, both are working as very similar statement, but there is one difference in page filter and prefix filter. In prefix filter, you actually write the value of your row key, right? You're saying here 2. If you're saying here 2, then sometime you are saying your prefix filter as 1. So we are giving this value of prefix filter. Okay, this 1 is a value. Here this 1 is not a value. 1 is a number which is saying I want just one row key. So this is like a limit 1. You're running a query, select a start from table name where limit is equal to 1. The output in this format can be used. This is for real world application only. HBase we are not using for just a POC or learning purpose. So in real time, whatever syntax I'm running, I can directly check that in HBase cell. And second, I can connect using programming language like Python, Scala, and Java also. So they have exposed API. Whatever query you are seeing here is scan option, then you have seen put option, input put option, delete option, all that we can run using using a programming language also. So both are allowed. I was there in page filter one. Page filter one is like limiting your query till one. This is like select a star from table limit is equal to one, right? So this is giving me one result. Suppose I give two also. So this will give me two row key result. So it's very similar as limit. Only difference between prefix filter and page filter. Prefix filter is giving you result in number. You have to know the number of value of the row key, then only you can use prefix filter. But page filter we can give limit. Then inclusive stop filter. In inclusive stop filter, we are writing the value to stop it. Inclusive stop filter, and here I'll pass the value. Suppose I want to stop this query till 1. So page filter is stopping it at second position, and inclusive stop filter is also limiting your result, but here you have given a number, general number. You want first row key, second row key, 5 row key, you can write 5 here, 5 row key result will come. Now what I'm writing this one is not a limit, this one is a number actually. So when I say inclusive stop filter, it will give me result of this one. If I set this as 2, then it will give me this along with this. Okay, so inclusive stop filter is also working as the same limit, but here we are passing the value. If I give 2 here, what will happen? It will go and stop till second point. So this is working based on the value. Suppose the value which is not present I'm giving, what will happen? This 4 is not present, but since 4 is coming after 3, so whatever result is present we will get here. I'm limiting till 4, but 4 row key is not present, that's why it is displaying us result till 3 column identifier. So in inclusive stop filter and page filter, I don't find much difference in this and in this query. Prefix filter is setting the row key for that number. It's not giving number from 1 to last. So you can check this, you can explore these options, create this table and run all this query. Now we will use a qualifier filter. So table name, filter, qualifier filter, and I'll give one binary result. Let's say this is card type. This is giving me, qualifier filter is giving me result related to this card type from all the row key. Okay, so we can set this binary for any column identifier. It will give us that result only. Suppose I'm giving amount AMT, this is giving me amount from all the row key. So this is like single column prefix filter. We have seen single column, this one column prefix filter, this line and this line. This is giving me without this line, if I write, this is the same query as qualifier filter. Then limit, if you want to use here in our table, we can say scan table name columns. Which column you want to search for? So you want to search for per colon bank. This is my column. This is my column family. This column family is txn underscore info. And here we have AMT. Then limit we will remove for now. Limit is good when you have thousand of result. So you said I need only top 2 result, top 5 result, top 7 result. So you can use limit there. txn info AMT filter value filter. So this query wise, if you check the syntax, they are slightly complex because we are coming from database background, relational database management system. So there we have seen a different kind of query. Here in this, I'm not writing the full name. I'm only fixing the binary prefix. And let's give one prefix. So any value when you type, the first value of this letter, because you're running on AMT, transactional info AMT, how this query is working. You check this query on table called TXN, and in this TXN table, you are targeting on TXN info and in amount, which means this one. And here you said, I want result which are starting from 1. Okay, you are giving one prefix here that I want all the result which are starting from 1. So we have only one result which is starting from 1. That's how I'll get this result. Suppose I will give, so I have some entry as 9,000 and 9,500. If I give 9, then both will come. We can check that with this. If I give prefix as C, C should take me this row key result and this row key result also. Both results should come here in this query. So here I will change this card type, and binary prefix will give us C. C is in uppercase. TX and info row key. One second, it should come for both the result 2 and 3 both. Okay, actually 2 are saving only. First, so I should check with S. I have not 2 credit, I have 2 saving. So my mistake here, I gave this entry as credit. So let's change this to saving. This is a saving result. When I check with this S as prefix key, it is giving me this result also and this result also. So we have an option. This prefix is like a star. You use a star in your query. This is star in RDBMS. This star is like the same thing. Here we are using this prefix. So it will bring us all the data which are starting with this character, whichever is matching in this column family along with the column identifier. So prefix are very optional query. We will have to use limit here. If you want just one result, so you can use limit is equal to 1. So when you use this limit is equal to 1, the very first result you will get, and very first result is this one, TXN card type, and that is for row number 1. Okay. So limit will limit your result, and prefix will give you the result which is starting with that number. Last 2 more query on this scan. Table name, single column value filter. In single column value filter, you will give here your column family name. Column family name is txn underscore info, and this is column txn info. This is column identifier card type. Same thing, txn info is my column family, and this is my column identifier. I'll set this binary as S again. Okay, let's give this as SA V saving. So single column value filter is giving you result from that row key where we have saving result is stored. Okay, so saving is stored in this row. Saving is stored in this row and in this row, first row and last row. So it will give us result of this complete data and this complete data. This is like running a query select star from table name where card type is equal to 7, right? This query is exactly the same thing. This is a where condition using where card type is equal to 7 and get me from this column family because this card type is a part of this column family and this column family is inside this table. So you are running a query on table and you are giving the proper value that I want this value. Total result of that row key will be selected and brought up from there and displayed in your system. Then here we can use other query also, like suppose I'm checking for amount, I'm searching for amount and I need only this result, let's say 5501. Here I'll give select star from table name where amount is equal to 5500.00. So all that row key will come. This row key is coming for this result. So these are the filter operations. You have to see these operations one by one and start checking in your system. So how Zookeeper will come in this picture and what is the use case of different daemons, we'll check them tomorrow.